video about electrons and how we see light. So we've learned that the model of the atom has evolved over time. In the beginning, there wasn't much to it. Not many subatomic particles were invented yet. And so as time went by, more scientists added to what we know as our current day model of the atom. So electrons in an electron cloud around the nucleus, and protons and neutrons inside the nucleus. So it's changed over time, and in the earlier days there was a scientist named Bohr who came up with this idea of the planetary model. But like I said, by the 1920s, scientists knew that Bohr's model was not completely right. For today's lecture, having Bohr's model with these nice concentric rings around the nucleus is kind of an easy way to explain electrons. And so though we know it's not completely right and that there's more of an electron cloud now, this is okay to still use as a model. Okay, so let's take a look at that model to understand how our atom is set up and how electrons are arranged. That's our focus, is about how electrons are arranged. So we're moving away from the nucleus and looking at the electrons. Okay, so around my nucleus are these pathways, and Bohr called them energy levels or shells. And within these energy levels, there's more layers to it. There are electrons that reside in these energy levels. Energy levels are represented by the letter N. So N equals 1 is the first energy level that's closest to the nucleus, and then 2 and 3, and you can have infinity energy levels, though about 7 is more common. Within an energy level, or a shell, is an orbital. So we start to get into more and more detail. Okay, so within an energy level is actually a sublevel comes first, and then an orbital. So think of them as layers. You have your energy level, and within the energy level is a sublevel, and then within the sublevel is an orbital. Now the easiest way to think of this is to make an analogy. And here's my analogy. A hotel. So in a hotel, there are floors, right? The level which you're on. You know, you could be on floor 1, floor 2, floor 3. So an energy level is like a floor. Within the floors, you find rooms. Within an energy level, you find sublevels. So sublevel is like a room. Within the rooms, if you open the door, you'll find some beds. Within a sublevel, you'll find orbitals. So that's kind of the layering that's happening here. If you could think of yourself in a hotel, standing on a certain floor, then you're on an energy level. If you find your room on that floor, then we call that a sublevel. If you open the room and see the bed, then we call that the orbital. And what's inside the orbital? Well, that's exactly where you'll find electrons spinning around. So within the orbital is the specific part where you'll find electrons. It's kind of like saying, what will you find in the bed? You're like the electron. You're the important part. Okay? To go back to our idea that we had here about all these energy levels represented by the letter N, the energy level that's closest to the nucleus is also, it has another name. Not only is it N equals 1, but it's also called ground state. It's known to have the lowest energy. So each energy level has an energy associated with it. The one closest to the nucleus has the lowest energy. Okay, so just a few things you want to remember about electrons. So a few things to remember about electrons that you already know is that an atom, here's our periodic table, found on the periodic table. Here's hydrogen, right? It has the same number of electrons as protons if we're talking about a neutral atom. So hydrogen has 1 proton, seen here by its atomic number. So it also has a total of 1 electron. Beryllium, seen here, has an atomic number of 4. It's in the second column. And it also has 4 protons, which is equal to 4 electrons if beryllium is neutral. Okay. Now, of those 4 total electrons, how many are valence electrons? Let's remember that. So some old topics coming back. Valence electrons are the most important electrons. They're the electrons in the outermost part of the atom, or another way of saying that, in the outermost energy level. Remember, the column numbers tell you how many valence electrons you have. So out of beryllium's 4 total electrons, 2 of them, right, 2 of them are found in the outermost. The other ones are inside. That's important to remember. The column number tells you the valence. This right here helps you know how many total there are, total electrons. Okay, so there are a few things that we're going to learn that are new, and that is, how do we see light? You know, maybe you're driving by a store and you see a neon sign flashing open, or you look up and you see, you know, shining disco lights at a at a school dance. How come we see different color lights? How come some light appears blue, others appear red, pink, and so forth? That has to do with electrons. Electrons are how we see light. So let's get into the details about that. Okay. So our first step here is that we've got an atom, and within the atom, if you remember, we have our electrons. An electron can actually absorb energy. Once an electron absorbs energy, that electron, we say, is excited. Then from there is step 2. Once that electron has the energy and is excited, it can now jump to a higher level. So take a look at this electron right here. It's at a lower level. Remember, closer to the nucleus is lower level. It's gained the energy it needs to make the jump to a higher level. So from low to high, it needs to absorb energy to do that. Okay, now, step 3. So far we've not seen any light yet. Here's the important part. The electron actually can fall back down to its original spot. When an electron drops down to its original level, so it goes back to its original level, falls back down, it releases that amount of energy it absorbed. It now releases it. It throws it out there. And when it releases that energy, it does so in the form of visible light. So that's the light we see. So anytime you see light, this is what's really happening. Electrons are falling back down to their original energy level and releasing the energy they had previously absorbed in the form of light. Okay? All right. Now, in class, we're going to be seeing this. We're going to be using a box, an electric box that we plug in. When we plug it in, that's our energy source. That's going to give energy. Inside this box, we're going to place a glass tube, seen here. Okay? And this glass tube is filled up with gas. And specific for this one, it's neon gas. You can't see it, right? Because gas molecules are so small and spread apart. So there's gas inside of here. I'm going to put it inside this electric box and plug it in. What happens? All the atoms inside have electrons. Those electrons are going to absorb energy, right? Absorb the energy. And as soon as they absorb the energy, they're going to jump to higher levels. And then they're going to fall back down and release that energy in the form of light. This happens very quickly, okay? So they're going to follow all of these steps, right? They're going to absorb the energy from the power source. They're going to get excited. They're going to jump to a higher level. We don't see light yet. And when they drop back down, they release that exact same energy, and that's how we see light. Different colors of light have different energies, okay? So light is actually made up of different colors. Light is actually made up of different colors, okay? So what's going to happen is, for us, in order to see that light is made up of different colors, what we're going to do is we're going to plug in that box, put in our tube of gas, and we're going to use a prism. It's going to look like this, a little viewing glass. And we're going to look through that prism. And what a prism does, if you don't know, is that it separates things out. Okay? So we might see red light shining. We're going to use our prism and look through it with our eye, and we're going to see that prism separate out the red light to show us all the different colors. And it's going to show up something like this. Right? We're going to see bands of color come out. Right? And we might see a band of red and a few bands of orange. That could be it. You could see blue, you could see violet, you could see green. It just depends. Okay? And again, why? Because it turns out that light is made up of different colors. We only see maybe red in this instance, but red is made up of red and orange. So we'll know when we actually use our prism to do that. Okay? What this basically told us was something really interesting, because since we know that light is connected to electrons absorbing and releasing energy, we can now conclude that electrons have only certain energy values, meaning they can only absorb and release certain amounts of energy. Okay? Because red has a certain amount of energy, and orange has its own certain amount of energy. Okay, so maybe this electron, when it jumps and it falls, it jumps to a higher level and falls back down, this energy needed to do this jump correlates to or relates to a red energy color. And maybe this electron, when it does its jump, it's going to absorb and release a certain amount of energy that relates to the orange color. Okay, so each color has its own energy associated with it. And if you see that color, then you know that that electron absorbed that amount of energy. Okay, good. All right, lastly, actually we'll stop there. That's the end of the video.